Hello everybody, welcome to Mustcourse.com's UC Irvine Math 2A webinar before the midterm. Before we begin solving the questions, just a few reminders. You can switch the quality of the video via the YouTube panel. So I suggest you to switch to HD quality that you can read my writing. And the most important thing is the chat panel. So you can ask your questions via the chat panel, and I will be following your questions, and I will try to answer immediately. So my name is Taylan, and I'll be your tutor for tonight's UC Irvine Math 2A webinar. And I believe that you will feel much better after our session. But if you ask your questions, if you provide feedback, and if you direct me, for example, if you find the question very easy, please write that to the chat panel so I can skip that quicker. Okay, so I have some sample midterm questions and I have some past midterm questions, and I will try to solve both. But as I said before, please tell me if something is too easy, or please tell me if something seems too hard and you need further clarification. Okay, so here we go. Before um, proceeding with harder questions, let's warm up with a very easy derivative question. So we have a function and we will need to find the derivative of this function, and which is, so the derivative of x to the power 5 is 5x to the power 4 minus the derivative of square root x is, as you know, 1 over 2 square root x, and plus what is the derivative of p to the power 6? So is that 6 p to the power 5? So I think that's here just to lead you to make that mistake, because p is a constant, p is a number, just like 3, just like 5, just like 10. So it doesn't mean that the letter p makes it a variable. So it's just a number. So you know that it's a number like this. So you know that the derivative of a constant is just 0. So it doesn't exist here. Okay? So please be aware that p is a constant and the derivative of a constant is 0. So we have 3 over x squared. We can write it 3 times x to the power minus 2, and the derivative is minus 6 x to the power minus 3. So which means that 5x to the power 4 minus 1 over 2 square root x and minus 6 over x cubed. Okay, this was a pretty easy derivative question. Now, this one seems a bit harder. So we have WT is arctangent, inverse tangent t. And we need to find the derivative of W, but at the point 3. So when t is 3, we need to find the derivative of W. So I'll just ask for your suggestion for this question. What would you suggest? So maybe you will feel that you need to know the derivative of arctangent. Is that so? Or can we do something different? Please write via the chat panel what you think. Okay, so what are we gonna do here? We have WT equals to inverse tangent t, and we need to find the derivative. So this is our first, harder question. So, do you have any suggestions? Please write me. And by the way, I will write something very simple. So if we have Wt is inverse tangent t, then we can write tangent W equals to t, right? So that is the definition of arctan. So if W equals to the inverse tangent t, then tangent W is t. So that is the key to solving this question. Then I proceed. I take the derivative of both sides with respect to t. So first, let's write it like derivative of tangent W with respect to t and derivative of t with respect to t. Okay? So take the derivative of both sides with respect to t. So I think we may not know the derivative of inverse tangent, but we all know the derivative of tangent function, right? So the derivative of tangent is secant square, which is 1 over cosinus, right? For example, secant x is 1 over cosinus x, okay? So we know that the derivative of tangent is secant square. So I have secant square w, which is the derivative of tangent w, but here we have the chain rule. So we will do that in a more detailed way when we solve an implicit differentiation question. But now I'll just say that we have the derivative of tangent w such as secant square w, but now I need to go through derivative with respect to t. So that's why I need to multiply that with dw over dt. Because when I write secant square w, it's just the derivative with respect to w. But I need the derivative with respect to t. Therefore, I need to multiply by dw over dt because I don't know dw over dt. That's the thing. Okay, so now we have something very, very straightforward. dt over dt, which is dt over dt. What do you think? It's not something, tricky. It's something very straightforward. dt over dt is just 1, right? So what we have is secant square w times dw over dt 1, which means dw over dt 1 over secant square w, which is cosinus square w, right? So let's say that w prime, which means, in this question, the derivative of w with respect to t, cosinus square w. So now I need w prime, and I have a parenthesis here, and I have a 3 in parentheses. So I need that. What does that mean? That means since w prime is a function with respect to t, then that means that I need to find the derivative when t is 3. Okay? I need to find the derivative when t is 3. Then, when t is 3, I can find the variable w, the value of w. Then I can find cosinus square w. But I need something like w is tangent inverse t. So therefore, I need to find now tangent inverse 3. So this is another obstacle in this question. I don't know the inverse tangent of, right, 3. So I don't know by heart, when tangent is 3. But don't worry. I don't need to find w here. If you have a calculator in the exam, you can calculate that. But if you don't have, just don't worry. I don't need to know the exact value of w. I need to know the value of cosinus square w when t is 3. Then, just draw a triangle. And here, when you have w equals to tangent inverse t, then w is the angle, t is value of the tangent, value of tan. Okay, because remember, tangent w equals to t was our conclusion, right? Then w is the angle, okay? And t is the value of the tangent. So I have t equals to 3, which means that value of the tangent is 3. So what is tangent? Opposite over adjacent. So 3, 1, and from the equality, I have square root 10 here, right? So now I know the triangle. I don't need to find the w. And now I can find cosinus w, which is 1 over square root 10. And I have cosinus square w, which is 1 over 10, right? Cosinus square w, which is 1 over 10. So I have the solution. I have the solution. Okay? So, which is w prime at point 3, which means that when t is 3, then w prime is 1 over 10. Okay? So, that seemed a hard question, but we solved that question without knowing the derivative of inverse tangent. Okay? And at that point, you can give me some feedback. So can you understand clearly? And, do you need questions from other topics? You can write me the topic that you have the most difficulty. Okay? Please give me some feedback via the chat pad, right? So I have another easy question, which is like y equals to e to the power x over 1 plus 3x, and I need the derivative. So it is just the quotient rule. What's the quotient rule? The derivative of f over g is derivative of f times g minus f times derivative of g over g square, right? So let's do that. Derivative of e to the power x is the same, e to the power x, times, and write the denominator exactly the same, 1 plus 3x minus e to the power x, nominator, times derivative of the denominator, which is, the derivative of 1 plus 3x is 3 over the square of the denominator. So which is like e to the power x times 1 plus 3x minus 3 is 3x minus 2 over 1 plus 3x square. Okay? So that was a pretty straightforward derivative question. And the next one, gx equals to ln x, and I need the second derivative of g. So the first derivative is 1 over x. Therefore, the second derivative is, this is x to the power minus 1. And therefore, the second derivative is minus x to the power minus 2, which is minus 1 over x squared, which is minus 1 over x squared. And now another good question. Our theta is sin theta, and find the 25th derivative of r. So when we see this question, we can immediately think like, oh, am I going to take derivative for 25 times? No. So I will try to create a loop, right? R theta is sin theta. The first derivative is cos theta, right? The first derivative is cos theta. The second derivative is what is the derivative of cosinus? That is minus sinus. So minus sin theta. The third derivative is, okay, minus sin theta. The derivative of minus sin is minus cos theta. And the fourth derivative is, the derivative of minus cos is minus cos, which is sin theta. Oh, so we have just completed cycle, right? So the fifth derivative, as you can guess, is cos theta. So I will proceed with the other values of the cycle. So therefore, I have a cycle in every fourth derivative. So therefore, I'll think the location of the 25th derivative, okay, in this cycle. So 25 is equivalent to 1 in modular 4, right? Therefore, r 25th derivative of r equals to the first derivative of r, which is cos theta. Okay? So therefore, I don't need to take the derivative for 25 times. So I'll just, create or find out the cycle, and then I know that the length of the cycle is 4. In every 4 derivative, I go back to the same values. Okay? Then the 25th derivative is equal to the first derivative. Okay? So that was a nice question, I think. So now the equation of the tangent line to the curve with this equation. So I repeat again. What is they asked us to find r theta equals to cos theta and find, okay, what if it was cos theta? Okay, what if it was cos theta? So I can find another cycle. This is another question. Our friend asked, what if r theta is cos theta? Okay, then now I need the 25th derivative again. So let's find out. R prime theta is minus, what's that? Minus sin theta. And second derivative is minus cos theta. And third derivative is, what's third derivative? Sin theta. And fourth derivative is cos theta. Okay, so again, I've reached a cycle in 4 differentiations. So which means that 25th derivative is exactly the same as the first derivative, which is minus sin theta. Okay? So that was another question and another answer. But the solution, the way of solving the question is exactly the same. Okay, guys, so now I will proceed with the next question, but I remind you, please use the chat panel more actively. Okay, if you provide me more feedback, then I can help you better. Okay, so until now we have solved some questions and you have an idea of what I'm gonna do, but at that point you can give me feedback and you can, for example, write the questions that you have the most difficulty, right? The type of questions you can write here, like implicit differentiation. You can write here like problems of half-life, for example, or here there's another problem like, you know, there's another question in the sample midterm, like the meaning of derivative, and we have many types of questions. For example, we have a problem like this. So you can direct me and you can provide me more feedback. Okay, so find the equation of the tangent line to the curve x squared plus 2 over p cosinus py plus 4xy equals to 3 at the point 1 over 2. So which means that x is 1 here and y is 1 over 2 here. So the equation of the tangent line to the curve. Okay, exponential functions and half-life functions would be appreciated after the current example is done. Okay, I will solve that. I will solve both. Please find the second derivative of sinus x over x squared. Okay, I will do that too. Half-life, please. Okay. Okay. Don't worry, guys. And good. Please continue with providing feedback. Okay. So, and this question, you know, the equation of the tangent line and the implicit differentiation questions are asked in any calculus, you know, exam. So this is one of the key questions for derivatives. So let's think that as a curve, as a function, and the tangent line, for example, at that point, what is the connection? The derivative of the function dy over dx at that point equals to the slope of the tangent line. You know that, right? That's the definition of the derivative. So the slope of the tangent line is the value of the derivative of the function at that point. So I need to find dy over dx at x equals to 1. Okay, so I will write that. So my aim is reaching y prime when x is 1. Okay, that's my goal. So now I write the equation. So cosinus py plus 4xy equals to 3. I write the equation. So now you are all used to finding dy over dx when we have y equals to a function of x. That means when we have the y, the function of x, in an explicit form, it is easy. And this is an explicit differentiation. But now we don't have an equation like y equals to a function of x. We have y and x in a mixed way. So this is an implicit equation in that sense. Okay, and therefore reaching dy over dx by using this equation is named as implicit differentiation. So what do we do here? We take the derivative of both sides with respect to x. Okay, so we are doing implicit differentiation now. So please tell me if something is not clear, because implicit differentiation is very important to solving a set of questions. We will take derivative with respect to x. Okay, so now think that both x and y can be differentiated with respect to x. Okay, so let's begin with x squared. The derivative of x squared with respect to x is very easy, which is 2x, right? So now we have 2 over p times cosinus py. So now think that like a function of y. So we have a function of y. Okay, here we have a function of y. So think about the chain rule and think about, going down some steps. We have two steps. First, differentiate with respect to y, and then differentiate with respect to x. So these are our two steps down. So first, concentrate on the derivative of 2 over p times cosinus py and differentiate that. 2 over p is a constant. I write that times the derivative of cosinus, which is minus sinus py. And now the chain rule applies, as you see. Times now the derivative of cosinus py. So now I have to think about the derivative of py with respect to y, which is p. Okay? But now I just took the first step. Now I need the second step, the derivative with respect to x. Do I know the derivative with respect to x, the derivative of y with respect to x? No, I don't. So just write that. So that unknown will lead me to the solution, okay? Because I will find y prime if I have that somewhere in the equation. So don't be afraid of writing that as an unknown. We don't know the derivative of y with respect to x yet. So just write that as an unknown. Plus, now product rule. The derivative of 4xy is a product rule. The derivative with respect to x, so this is 4y, plus write x and the derivative of y with respect to x. Do I know that? No, y prime equals to, what is the derivative of 3? What is the derivative of 3 with respect to x? Any answers? So I need to differentiate 3 with respect to x. So what is the answer? It is 0, because 3 is a constant, so it doesn't change. So its derivative with respect to anything is, of course, 0. Okay, so now please be aware that I don't need to find the derivative of y with respect to x as a function. I just need this. So I just need this derivative when x is 1 and y is, what was y? 1 over 2. So please use that if you have a question like that. If you are asked, like find the derivative of y with respect to x in a functional form, okay, do that. But if you just need the derivative at a certain point, then use that. So now I need to solve this question by replacing 1 with x and by replacing 1 over 2 with y. So 2 times 1 plus, and these p's cancel out, 2 times minus sin, p over 2 y, because y is 1 over 2, times y prime 1, because now I am trying to find y prime at a certain point, plus 4 times 1 over 2 plus 4 times 1 times y prime equals to 0. Okay, so let's solve that. 2, so sin pi over 2 is 1, so it's like sin 90 degrees, plus, or let's say minus 2 y prime 1 plus 2 plus 4 y prime equals to 0. So 2 y prime 1 equals to minus 4, y prime 1 equals to minus 2. Okay, so now I have the slope of the tangent line. I have the slope as minus 2, and I have one point, which is x is 1, y is 1 over 2. I can find that line. That's pretty sufficient to find the equation of that line. So y equals to mx plus n, right? So this is the equation I will use. Y equals to minus 2x plus n. Just to find n, I replace the values. 1 over 2 equals to minus 2 times 1 plus n. And n is 2 plus 1 over 2, 5 over 2. So the equation is y equals to minus 2x plus 5 over 2. Okay. Okay. So, do you have any questions about this solution? Because, as I said, implicit differentiation will be very important in your exam. So, a bit of your questions first. The second derivative of our friend Carmen asked the second derivative of sinus x over x squared. Okay, let's begin with the first derivative, right? I will apply the quotient rule, which is the derivative of sinus cosinus x times x squared minus sinus x times the derivative of x squared 2x over x to the power 4, right? So this is the first derivative. This is the first derivative, and I'll need the second derivative, but to take the second derivative easier, I will write this in two parts. The first one, cosinus x over x squared minus sinus x, 2 sinus x over x cubed. And then now for the second derivative, I'll differentiate these two parts, separately. The first part, again, quotient rule, minus sinus x times x squared and minus, due to the formula, cosinus x times 2x over x to the power 4. This is the first part. And the second part, I write the minus and I take the parentheses, don't forget that. And also, just a minute, I write the minus and the 2, okay? So, and cosinus x, x cubed minus sinus x, 3 x squared over square of x cubed is x to the power 6, okay? So that is, and you can do some algebra, right? You can do some algebra to find a clearer solution. So, Denmark asked the question like limit. Okay, I'll go back to limit later. First, half-life and exponential function questions. I already have a half-life question. And Carmen, can you tell me whether this solution was sufficient, was clear? So, okay, the half-life question. The half-life of antiatertonium is 50 years. Suppose we have a 1024 milligrams sample of that matter. Okay, you are very welcome. Find the mass remaining after 150 years. So when you have something like that, you know that 150 over 50, you have 3 half-lives, right? So which means that the current mass, so I'll write that in a more, let's say, mathematical way. M, the mass at 150 years equals to the initial mass times 1 over 2 to the power 150 over 50, right? So since we have 3 half-lives, so we have new mass, which is the initial mass divided by 2 over 3 and divided by 8. So therefore, M the mass at 150 years is 1024 times 1 over 8, which is 1024 over 8, 128. And I think the second one is the one you have a bit difficulty. How long would it take the original sample to decay to 30 milligrams? So now I have MT is 30, and I need to find T. So MT equals to, let's write that, M0, the initial mass, times 1 over 2 T over 50, right? Because, T over 50 is the number of half-lives. So the number of half-lives is the power, and therefore I have a very clear formula. 30 equals to, which is the initial mass, 1024 times 1 over 2 to the power T over 50. So 2 to the power T over 50 equals to 1024 over 30. And I need T over 50 not at the power, at the base. So to make that, going here, I need to take logarithms of both sides. And I can take natural logarithm, ln. So, you have the ln function in your calculators. So ln 2 to the power T over 50 is ln 1024 over 30. Okay? So T over 50, because this is the move, times ln 2 equals ln 1024 over 30. So T over 50 equals to ln 1024 over 30 over ln 2. So I write that to my calculator first, ln. I write ln, and I open a parenthesis, and I write 1024 over 30. I close the parenthesis, and I say divided by ln 2, and which gives me T over 50 is 5.093, and I multiply that by 50, and which is 254.655 years. Okay, this was a half-life question. So is that clear now, the half-life? Can you scroll up when you finish the problem so I can see all the work? Okay, Ariella, a reminder, YouTube loads the record of the video, so you can watch that after our session. Okay, so you will be able to watch the record of the video in our YouTube channel. So that's the half-life question. Okay, that works for the half-life. Thank you. You are very welcome. And one exponential modeling, I guess, right? Exponential modeling question. So which is okay, this one, right? So is there any further way to simplify that value if we do not have a calculator? Okay, so maybe there are no okay. So then let's think about that. So we have a half-life okay. So we have the new, let's say, mass as 30 milligrams, and the initial mass is 1024. The initial mass is 1024. So we have 1024 over 30, which is 34 times, let's say, 34.13. Okay, so times smaller, which means that three, let's say, five half-lives, which means 1 over 32, so which means 32 times smaller, and six half-lives is 64 times smaller. Okay, just one point, just one moment. The question is a half-life question, and your friends asked me whether we can solve that. We can solve that without using a calculator, and I'm trying to show that. So therefore, it is very close to 5 half-lives. It is very close to 5 half-lives. So which means that, the half-life is 50 years, and 5 half-lives is, 250 years. Okay? 250 years. So, and, you can maybe approximate that 250 years if you don't have a calculator. Okay? But otherwise, the formal solution is the one with logarithms. Okay, guys? Can you use the e to the power kt equation to solve the problem? Okay, so our friend asks, can you use the c times e to the power kt equation? So let's say that mt equals to m0 times e to the power, let's say, minus kt, because let's say that k is positive and the mass is decaying, so therefore this is a negative, so negative power. But when mt over m0 is 1 over 2, then t is 50 years. Okay, t is 50 years. So to find k, we need, what are we gonna need? So 1 over 2 equals to e to the power minus k times 50. Am I correct? Because when t is 50, we have the half-life. So when t is 50, we have mt over m0, 1 over 2. Therefore, to solve this and to find k, you still need the natural logarithm. ln 1 over 2 equals to minus k times 50. So k equals to ln 1 over 2 minus 50, and you still need the natural logarithm to solve that. Okay, so of course you can solve that in that form, but still you need the natural logarithm to find the exact equation. Okay, so I will solve another exponential decay question, point taken, and please write me the topics or questions you need me to solve. And let's take a 15-minute break now. Let's take a 15-minute break now, and let's proceed with the questions in the second part. But please write your questions via the chat panel, and that I will be able to solve them after the break. Okay? So now we are gonna take a 15-minute break, and we will begin with the second part at 11, right? So, but I will begin with the second part by solving an exponential decay question, and there was a limit question, um, and also I want to solve a problem type question like this one. Mm, just a moment. Yes. So, like a problem type question, which is like finding the derivative when we have some, let's say, tank filled with water. And also, in the 15-minute break, please write me your questions or the topics you have the most difficulty, and I will solve them after the break. Okay, see you here at the same link 15 minutes later. Okay, so let's begin with the second half of our webinar. So I have your questions. I was going to solve a linearization question anyway, and we will talk about the exponential growth, and also we have that problem type question. A tank is being filled with water. Okay, so while everybody gets to get here, just a quick reminder. So we want to continue with these webinars. So they will be, as you can see, exam specific before your exam. Just covering the content of your course and in an interactive way. So we want to do that more and more. And also we want to organize more seminars at UC Irvine, maybe for other courses as well. But definitely we want to do Math 2A during the finals, okay? So, but of course, to make it permanent, to make it sustainable, we need some support. So as we wrote here at the chat panel, we will highly appreciate if you can support us. And we have a Venmo address. You can Venmo Alara to support us and to encourage us to continue with these webinars at UC Irvine. Okay, guys? So, first, exponential growth question. Is everybody here? So, just um, write me if it is okay to begin with the second half. So, the question is, the population of bacteria in a petri dish is initially 1,000. After 4 hours, the population grows to 7,400. Hint for simplifying your answer, ln 7.4 is 2. So you asked me whether the questions can be solved without using a calculator. But here you see that in the exam, the necessary logarithm is given. So therefore, we can use the logarithm and we know that necessary logarithm will be given. Okay? So we model this population growth, mathematical model for growth. What are we going to do? We will write that as an exponential function, right? So we will write population at t equals to population at time 0 times e to the power kt. E to the power kt. So this is the model for population growth. So we need to find the relative rate of growth, which is k, right? At this model, k is the relative rate of growth. So how are we gonna do that? We have the population value after 4 hours. We have the initial population value, and we have, of course, e to the power 4k. Okay, so after 4 hours, it is 7,400. The initial population value is 1,000 times e to the power 4k, right? So now just divide both sides by 1,000. 7.4 is e to the power 4k. Take natural logarithms of both sides. ln 7.4 is 4k, and in the question we are given that ln 7.4 is 2, can be approximated to 2. 2 is 4k, k is 1 over 2, which is the relative rate of growth. So that's so easy. See, how long does it take for the bacterial population to reach 12,000? C. So we have the model again. What is that? Pt equals to P0, so 1000 times e to the power 1 over 2t, right? So Pt is 12,000 here. 12,000 equals to 1000 times e to the power 1 over 2t, and 12 equals to e to the power 1 over 2t, and take natural logarithms, ln 12 equals to 1 over 2t, and t equals to 2 ln 12. So you don't have calculators, that's why leave the solution like that. And also now we can think about the previous question. Where was that? So the one with the half-life. So what did we do? We have calculated the logarithms here. Maybe we didn't need that. So just forget about this answer, this approximation. Let's leave that like this, right? So t equals to 50 times ln 1024 over 30 over ln 2. You can write that in the exam. And this is a perfectly correct answer, right? So you don't need to calculate the ln's. And you can give the answer like this. Okay, that's my solution for not having a calculator. And this is the solution for our exponential growth question. So I would like to proceed with the volume of the tank question. So the derivative of the volume, right? So a cylindrical tank with radius 5 meter is being filled with water at a rate of 3 meter cube over minute. How fast is the height of the water increasing? So just think about a cylinder. So the volume equals to, we know that formula, pi r square times height. Okay, so that equation will be the key to the solution. Now, one thing about this shape, radius, we just fill the tank with water, and height changes, but r is constant. Height changes, but r is constant because, the water is like being filled from the bottom to the top. So height changes, but r is constant. So I can treat r as a constant. So volume equals to P times 25 square root of 5 times h. And what am I going to do? So now, what is this? Just think about what is this information? Being filled with water at a rate of 3 cubic meter over minute. So this is the change in volume, dV over dt, right? Because the water fills the tank, and every minute, volume increases by 3. So therefore, I can take the derivative with respect to t, dV over dt equals to 25 pi times dH over dt. Now, you can see the end of the question. So 3 is 25 pi times dH over dt. Therefore, dH over dt is 3 over 25 pi meter per minute. Okay, so that is the solution. That is the solution. So what did we do? We began with the volume equation and we differentiated both sides with respect to t. With respect to t. So there was a question, is that as complex as it would get about this question? So I don't think. So this is just, writing the volume equation and differentiating with respect to t. So do you have any questions? Do you have any questions for this volume of the tank type of questions? Please tell me. Otherwise, I will proceed with the linearization. I will proceed with the linearization, and you can continue with writing your suggestions. Okay? Okay, find the linearization of the function fx square root of x plus 99 at a is 1, at a equals to 1. Use this to approximate square root of 102. So linearization, the formula is linearization at a, the formula is fa plus f prime a times x minus a. So perhaps you all know the formula, but I would like to talk about what this formula means. For example, let it be the graph of square root of x plus 99. And I will linearize that. At a equals to 1. Okay? At a equals to 1 here. So, and I will use that to approximate square root of 102. What do I do? Let's say that this is the point where I have f1 square root of 1 plus 99, and that is square root of 100, and here this is the point I would like to reach. What I do is, let's magnify that. Here is the function. This is the point I know, and this is the point I would like to reach. So I do linearization. I say that, here, draw a direct line between these points, and so this distance is f prime a times x minus a. So I approximate this distance as f prime a times x minus a. So as you can see, this is an approximation. This is not the exact value of square root 102. This is an approximation. So this approximation will be better as long as I am close to the point of which I would like to find the value. So therefore, linearization of, so let's say, use this to approximate square root of 102, which is 3 plus 99. Linearization when x is 3 equals to f1 plus f prime 1 times 3 minus 1. So let's remember that fx equals to x plus 99, f prime x equals to 1 over 2 square root of x plus 99, right? So by using these, I can find that f of 1 equals to square root of 1 plus 99, which is square root of 100, which is 10. And f prime when x is equal to 1, which is 1 over 2 square root of 1 plus 99. So which is 1 over 20. Okay? So therefore, I can proceed with the linearization. So the linearization when x is 3, so the approximate value of square root of 102 equals to f1, which is 10, plus f prime 1, which is 1 over 20, times 2. So therefore, this is 10 plus 1 over 10, and which is 101 over 10, which is 10.1. So I write square root of 102 to the calculator. It is 10.0995. So pretty close, right? Since 102 and 100, they are pretty close, we have a very good linearization. Okay, that was the linearization question. And let's go on with some implicit differentiation question. But as I said, I am still open to taking your suggestions. Please direct me. Okay, this one is good, but before that, some implicit differentiation would be fine. Okay, so for example, this one. Find dy over dx by implicit differentiation when x times cosinus y plus y equals to x squared plus 1. X times cosinus y plus y equals to x squared over 1. So, to find dy over dx, we take the derivative of both sides with respect to x, right? So, first, the derivative of x times cosinus y plus y with respect to x. So, this part is a product of two terms. Therefore, I will apply the product rule. The derivative of x is 1 cosinus y plus right x times the derivative of cosinus y first with respect to y minus sinus y times y prime. Don't forget that. First, derivative with respect to y, and then derivative of y with respect to x. Okay? So, plus, we have a y here, so derivative of y equals to derivative of x squared plus 1, which is 2x. Now, in this question, we have to find dy over dx as a function. So we cannot, leave the derivative at a certain point. We need to find a functional form. Therefore, what I write is, I will gather y primes at one side, and it will be something like y prime times x times minus x times sinus y plus 1, right? Equals to 2x minus cosinus y. Therefore, y prime equals to 2x minus cosinus y over minus x sinus y plus 1. Okay? So that is finding the derivative as a functional form by implicit differentiation. Okay, guys, in the second part, you have not given any feedback until now. Please, write your questions, write the topics you want me to solve questions about, okay? Or write the parts you don't understand. So let's continue in an interactive style, okay? So, and for this question, I really wonder your answers. So that's why I will read the question and I will wait for your answers. Suppose CS is the total cost in dollars of building a home with S square feet of space. So S is the square feet of home space and C is the total cost. So therefore C is the cost and the cost changes with respect to S. Okay? First question, what are the units of C prime S? So this is directly related to the meaning of the derivative. So what is C prime S? What is the meaning of it? It means dc over ds mathematically, which is, when the home space increases by 1 square feet, when home space increases by 1 square feet, cost changes by how many dollars, right? Therefore, the unit must be, so what is the unit of cost? First, think about that. And second, the unit of home space. So this is square feet. And what is the unit of the cost? It is dollars. So dollar over square feet. That's it. The second one, what is the practical meaning of C prime S for this problem? I write that, which is when home space increases by 1 square feet, how many dollars does the cost of building change? And the third question is C prime S positive or negative? Why? So I leave that to you. What do you think? So when square feet increases, what happens to the cost of building? Positive, right? Correct. C prime S is positive because when home space increases, cost increases. That's pretty straightforward. forward. Okay? So therefore, we have the meaning of the derivative in this question. Okay? So, there was a limit question. It's like f of x equals to sinus x over x plus tangent x. I did not try to solve the question before, but I will try. So the question is limit as x goes to 0. Okay, limit as x goes to 0. So we have f of x as sinus x over x plus tangent x. When x goes to 0, we have sinus 0 over 0 plus tangent 0, and therefore we have 0 over 0, and it is indefinite. Therefore, we should do something to find the derivative. And the first thing I can think of is applying the L'Hopital rule. So derivative of sinus x is cosinus x over derivative of x plus tangent x is 1 over secant square x. So, and replace x with 0, cosinus 0 over 1 plus secant square 0. So cosinus 0 is 1 over 1 plus secant square 0 is still 1 because cosinus 0 is 1. 1 over 1 is 1. Therefore, 1 over 2 is the answer of the derivative. Okay, guys, I will continue with the questions I have prepared before, but if you want this session to be longer, please tell me what you would like me to solve. Okay? Please do that. So, we have y equals to an exponential function. So we have y equals to x to the power sinus x, and we need to find dy over dx. So what are we gonna do? We have x to the power sinus x, and we need to find dy over dx. So we have both x's on the base and on the power, x to the power sinus x. What would you suggest? What would you suggest? Okay. So we have y equals to x to the power sinus x. Therefore, I need this sinus x not at the power, but at the base. So therefore, I take the derivative, the logarithm, natural logarithm of both sides. ln y equals to ln x to the power sinus x. ln y equals to sinus x times ln x. Okay? So now to find dy over dx, I apply implicit differentiation. I take the derivative of both sides with respect to x. d ln y over dx equals to d sinus x ln x over dx. And first, let's take the derivative of ln y with respect to x. As I said before, first the derivative of ln y with respect to y. 1 over y times now the derivative of y with respect to x, dy over dx. This will lead me to the solution. Equals to now the derivative of sinus x times ln x, which is first the derivative of sinus x cosinus x times ln x plus sinus x times the derivative of ln x, which is 1 over x. So dy over dx is y times cosinus x ln x plus sinus x times 1 over x. And I can replace y with x to the power sinus x because I know that is the equation. Dy over dx is x to the power sinus x cosinus x ln x plus sinus x times 1 over x. Okay? So we have a question like the derivative of x squared times sinus 3x. So I will apply the product rule, right? First, the derivative of x squared, which is 2x times sinus 3x plus x squared times, sin cubed. Okay. So this is x squared sinus x cubed. We will take the derivative 2x times sinus x cubed plus x squared times, let's take the derivative of sinus x cubed. First 3 sinus x squared, right? According to chain rule, times the derivative of sinus, which is cosinus x. That is the derivative. First, we have taken the derivative of the first term, then the second term is written exactly it is, then the derivative of the second term and the first term is. Why did we have to use the chain rule for the second term? Because when you have to take the derivative of sinus x cubed, you need to use the chain rule. Why? First, think that you want to take the derivative of sinus x cubed with respect to x, okay? But you need to create an intermediate step. This is like sinus x. First, sinus x cubed with respect to sinus x, which is like 3 sinus x squared times the derivative of sinus x with respect to x, which is cosinus x. Okay, guys. So we have covered many topics. We have solved many types of questions. I hope that this webinar was helpful for you to prepare for your Math 2A exam. And as I told you before, you can watch the record at the same link. YouTube loads the record at 10 minutes. So we want to continue with our webinars at UC Irvine, and for Math 2A, we want to do the same for the finals. And I thank you all for attending the webinar. And if you would like to support us, you can donate to the Venmo account given above. Okay, so I hope to see you at other webinars, and specifically at Math 2A final webinar. And please write us. Please write us at contact@mustcourse.com. So if you have any suggestions, if you have any requests to organize new webinars, okay. I wish you a very successful exam tomorrow, and I hope to see you at other webinars. Good night.